Welcome to Hacking the Box, guys. Our first speakers are from France, Sebastien Renaud and Kevin Szkudlapski from, what was it again? Szkudlapski. Please welcome them.
So welcome to our presentation about Windows Runtime, which is a feature of the next operating system of Microsoft, Windows 8. I'm Sebastien, and with my fellow worker, we'll present you our agenda. So we do a quick presentation about Windows 8. And in the next part, we will talk about WinRT, which is the Windows runtime. WinRT on applications and components. That is how applications are built, how they are packaged, how they are installed, and what are applications capabilities. Next, we will talk about Windows RT internals. That is how applications are started, how different languages can be used and are unified through the application binary interface, and also the component object model. And we will see how objects are built and how they can be used in the Windows runtime. Next, we'll talk about the Windows Store. Some words about the Windows Store. We'll see what is the vision of the Windows Store from Microsoft. And next, we'll talk about the sandbox. And we'll do a comparison between the sandboxes of Windows RT and the sandbox of the Chrome browser. And we'll see how Microsoft has implemented the sandbox of WinRT. So, how it started. At first, we were searching for something new in Windows 8 when it was released as the developer preview.
Very good. We have some problems with the microphone setup, so I'm just going to give you this mic.
Yeah, thanks. So at first we were searching for something new in the Windows 8, and we said, let's see what's new in the Windows 8 kernel. So we have simply diff the Windows 7 RTM kernel and the Windows 8 developer preview kernel, and we stumbled across a function which was interesting just by its name, and its name is anti-create logbox token. So unwinding the thread, finally in a bottom-up approach, we find that it's related to the Windows runtime or WinRT. So we'll see what is the Windows 8 new interface. It's called Metro. So if you haven't seen already Windows 8, we just take a quick look. So this is Windows 8 when you log in. So as you can see, the desktop has been replaced by the Metro desktop. So it's composed of tiles, and the desktop is now a tile with other applications. So this is the usual desktop as you have seen from previous releases of Windows. As you can see, the the start button has disappeared. So Metro style apps are also called immersive applications, and Windows RT is also the backbone of Metro applications, and it can also be seen as a new programming model that target the Windows 8 application. So we'll see what are the Metro application key points. So Metro application are distributed only through the Windows Store. This is a new feature of Windows 8. So if you want to install a Metro application, you have to go through the Windows Store. You cannot install an application without going through the Windows Store. It's an important feature because you can do without it. Applications are executed in what is called an app container. An app container is a process that is secured through a sandbox. It has severely limited resources access, and if you want to access a feature of the operating system, you need an explicit permission. Explicit permissions, which is given by the developer of the application. And finally, Metro applications are using a restricted subset of .NET and Win32 APIs. So this is a big picture of WinRT. As you can see, it's split in two parts. There is the on the side the desktop applications, as they can be seen in previous Windows operating system release. And the new part is about Metro style applications. As you can see, there is the WinRT APIs at the base, which can be targeted by different languages like C or C++, and .NET languages like C# and VB.NET. If you want to program a UI for these languages, you can use XAML. And you also can use JavaScript with HTML and CSS to target the WinRT. One thing that is important is that in this slide you can see that Win32 is at the base as of the desktop applications, but in fact Win32 is still at the base of Metro style applications. It's really still at the core of WinRT. It's also used with the component object model. So applications that are used for the Windows runtime, Metro applications, are installed by user. This is an important feature because if you install an application, you install for the current user. And by this means, you do not need administrative privileges to install an application. Applications are packaged through for deployment in Apex packages, which are in fact simply zip files. So the packages are compressed. There are also signed user certificates. And packages contains all needed files. So you don't need to rely on external files. For example, the only files that are required for your applications are .NET, for example, if you use a .NET language, or VC++ runtimes, which are also shipped with your application package. Packages can target multiple platforms like x86, x64, or ARM. ARM is a new feature of the upcoming Windows 8 system, because this is the first time that Windows is targeting the ARM system. For installing an application, you simply go through the Windows Store, and inside a package you have an Apex manifest.xml, which describes an application registration inside the registry. So the Windows registry is still at the heart of WinRT and Windows 8. So we'll see how is built a package. So this is a simple package of test application. So the Apex package is in fact a zip file. As you can see inside the package, we have our main executable test app.exe, which comes with, for example, in our with a component which is a DLL. Which is required by the application. So the DLL comes inside the package. And the interesting part is the Apex manifest, which is used during the installation of the package. So here's what looks like Apex manifest.xml file. It has the application markup, which is the main markup for, which is the core of the registration. So in fact, the Apex manifest is mapped inside the Windows registry, and during installation, all keys are in fact coming from this XML file. So inside our manifest file, we have application, which is the core of the registration, capabilities, which tell what the application is allowed to do, and extensions, which are, for example, our DLL. So it tells what the application can use. As we said previously, everything is mapped onto the registry in the HKCU key. So we have installed our application. So if we look into HKCU, which is a current user, we have our application is a software, and it has a classes. And if we get down, we can find our package, which is the test application package, inside the Windows launch extension. So what are capabilities? Capabilities, by default, an application is severely limited in what it can access. So capabilities are here to tell what the application can do. For example, capabilities can be regrouped into three main points. We have network, file system, and devices. For example, let's see if the developer wants to access the internet, it can tell during the development that his application needs to access the internet, so he needs to put the capabilities as a client of the internet. So without these capabilities, you can't access all of these things. So we have seen that everything is mapped onto the registry. So applications can be seen as classes in the registry. So contracts and extensions. For example, if you develop an application, it automatically implements the launch contract. The launch contract is simply for displaying the application tile in the Windows 8 desktop. So when a user tap or click the tile, it calls the launch contract. We can see that the extension is an abstract concept, in fact, while the class is a concrete implementation. For example, in our case, our test application is an extension of the file picker contract, which is just a simple dialogue to pick a file. You can't pick a file without asking the system at first. So, how an application is started. At first, the system will query the extension catalog to find the right extension. So everything starts in explorer.exe. When you tap or click a tile inside the Windows 8 desktop, it is explorer.exe that is called at first. So it simply checks the extension catalog and check if the right object can be activated. Once the activation takes place, explorer.exe sends a request to RPCSS. So RPCSS is a service in Windows which is running at the network privileges. It's a lower privilege. If the process is not already running, RPCSS sends a request to the DCOM launch service, which is running as a system service. And the application is started at that point. So we were thinking about doing some live debugging on stage, but debugging explorer.exe and RPCSS is quite a challenge. So sometimes when you are debugging RPCSS, if something goes wrong, you got a BSOD. So we choose to not debug on stage. At the base of Windows RT, we still have Win32 and COM. So COM is here by the fact that each object is in fact implementing IUnknown interface. Specifically for Windows RT object, we have the IInspectable interface. And the ABI, the Application Binary Interface, is here to unify all languages through projection. A projection, in fact, is easier to unify all language. That means that, for example, if you have programmed a component in C++, and you can use this component from another language like JavaScript or any .NET language. So this is what looks like a WinRT object. So the object is inheriting from IUnknown and IInspectable. It implements 3 interfaces, and its runtime class its file information. So we will take another simpler example. This is a simple example in C++. In fact, if you want to target the Windows RT, you can use C++ with components extensions, which is not really a new language, but an addition to the C++ language. In fact, everything in C++ with component extensions is mapped to lower level things like templates in C++ or come behind the scene. So this simple component is implementing 3 methods. We have multiply, divide, and divide. So here is the wonderful implementation. Each object, this component can be used like this. For example, in the test component method, we just create a new calc WinRT component object. We use the head method with 2 parameters and convert this method to this result to text. This is the same example, but this time we are using a feature of C++ by using this time the virtual function table of the object, because each object is in fact having a virtual function table. So here is how look like an object, a WinRT object. This is our calc component. At the base of the object, we have, in fact, the object is inheriting from a WinRT class, which is called object. At the base, we have the virtual function pointer. As you can see, we still have the 3 methods of IUnknown, which are query interface, addRef, and release. Each object is in fact a refcount object. The 3 other methods, get IDs, get runtime place, and get trust levels, are a method from IInspectable. IInspectable, in fact, is used for it's useful for JavaScript when you need to when you can't really call the query interface. It just IInspectable is used to get interfaces from your object. Following the IInspectable 3 methods, we have the methods that are implemented by our object. So we have ABI multiply, LBI add, and ABI div. These methods are in fact clearly using the ABI of WinRT. The ABI of WinRT is a standard calling convention, std call, with an addition that you pass this pointer in as the first argument. The object also have mul add and div methods, but which are not following the WinRT ABI. And here is the gore part of our talk, a little bit of disassembly. This is the same method that we have seen previously. This is this method with the head and convert to a string. So at first we have this is the constructor of the object, which in fact will activate the object. We have, as we can see, the vtable dereference, and the following is the head method, which is called inside the vtable at index 7. And following that, because it's a COM object, we have Windows delete string, which is using in fact a string object from Windows RT, but it's a COM string object behind the scene. And finally, we have a descriptor of the object. So we have seen how objects are built and used, and now I will let Kevin talk about how they are distributed through the Windows Store.
Okay, do you hear me? Okay, thanks. So as we saw previously, the Windows Store is in fact the unique way to download WinRT applications and share it. So Microsoft controls the whole applications. They can decide if they allow or not your applications, and they ask you to respect requirements. Basically, there is your application must be linked with several flags like safe SEH, dynamic base, and is compate. The application must be reliable. It must not hang or crash. And they also define a list of forbidden API. Basically, this is a Win32 API. Microsoft provides the Windows App Certification Kit. So since we are a big lover of Win32 API, we try to call a good old API and validate the check of App Certification Kit. Okay, to do so, we have to basically use well-known shellcode techniques, which we gather the address of kernel base, DLL, then we parse the PF format to retrieve the API which we want to call. Here, this is a CRUD process, which of course is forbidden by Microsoft. Okay, so if I click here, basically it spawns a CMD box. However, even if we succeed to call an forbidden API, as you can see, we are still in the app container. So we warned Microsoft about this issue, and according to them, they perform more tests and before deploying the applications, and they explain us that this ecosystem contributes a rise to confidence in Windows 8. For instance, even if the app certification kit was able to catch this problem, both additional tests from Microsoft and the app container for your own users allow to mitigate this issue. App container adds the list of capabilities, which we will detail later, and also add a new flag for the P headers. Basically, it tells that to create process, that the application must be run under app container. This is the exhaustive list of capabilities. As you may notice, it's mapped as SID, and we will see later why it is as such. Okay, so let's do a brief reminder about what is sandbox. Basically, it's a mechanism which allows to isolate untrusted processes. And usually, sandbox contain isolated process, also known as sandboxed process, which run with very limited rights. There are also a broker process, which allows isolated process to execute specific actions. In the WinRT case, it's capabilities. And finally, we found the IPC mechanism, which allow both sandboxed process and broker to communicate. Microsoft provides a bunch of API to isolate a process. Basically, we have the restricted token, which allow to disable or restrict an SID and delete privileges. We also find the job object, which, when assigned to a process, allow to limit access to desktop, clipboard, and so on. Forbid the creation of sub-process and restrict the use of CPU, memory, etc. It's one thing that on Windows, if there's multiple desktop, basically application can communicate across desktop. So if you want to isolate a process, you can simply create a new desktop and put the new process on this desktop. And finally, since Windows Vista, Microsoft designs the integrity levels. Usually, applications run with a medium level, but if you set too low, it's enabled to restrict access to only folders, app data, local law for the current user, and in registry in the software, app data law, once again for the current user. There is also an interesting feature which is UIPI, the user interface privilege isolations, which allow to forbid write type messages to a higher level process. Higher level integrity process. Also, if your application is on low integrity level, it will not be able to change its privileges. Unfortunately, there's some restriction about this API, like there is no way to forbid a process to call any syscall, like the semcomp mode in Linux. So imagine there's a vulnerability on a syscall. Basically, a WinRT application could possibly call this syscall and trigger the vulnerability. Also, there is some object which can be secure by design, like the FAT file system. Okay, so let's compare Chrome and WinRT. We decided to choose Chrome because it's a Windows sandbox implementations, it's open source and well documented, and it's designed for security only. Where App Container is more like Microsoft wants to put a software boundaries between processes. In order to compare them, we use several points like how the sandbox isolates the process, how the broker is designed, and finally how they can communicate. For Chrome, I know this sometimes is a bit confusing, but in fact, setting restricted SID as restricted makes access checks to perform a double check. It will first check if the access object allows the current token to access this object, and see if the restricted SID is also allowed. They also put most of the SID groups as disabled, which basically means that they can only use by deny-only policies. Isolation relies on job and desktop for Windows XP and integrated level for Vista and Plus. And it's worth noting that the application starts with normal writes, and the sandboxes process has to call a lower token to be isolated. On the Microsoft side, they decided to implement isolation in kernel. Basically, they modify the structure token, which adds several fields like package SID, capability SID, and design a new flag which tells if the token is in app container or not. If you want to create app container token, you must call nc-create logbox token, which do initialize the new files, set integrity level to low, and change access right to all access for itself and only query for administrators. They also modify the SCP access checks function, which basically allow or not the access to an object. And our current theory is that if the token is app container 1, they will perform an additional test to see if the access objects allow either the package SID or the well-known SID or application packages. About the broker, so in Chrome it's the same executable, so basically to know at runtime if you are in broker or sandbox, you have to call the get broker services method. They also decided to implement their own access policies. With WinRT, the broker is in fact a common interface located in runtime broker, which is automatically run by the service host process. And to perform the test, to know if the sandboxes process has a good capabilities, basically they have to impersonate the client to retrieve the process token, then they revert to self and call this new function which is checks token capabilities. This function basically do a call to NT-access checks to see if the process token on or not the good capabilities SID. Finally, about IPC, Chrome has to overcome a difficult problem because most of plugins are closed source and they must be isolated. To do so, they decided to implement the API hooking, which allow to the closed source plugin to call the Chrome function equivalent and perform the communication with the broker. In order to share parameters and results, they decided to use a shared memory and a duplicate handle to allow the sandbox process to notify the broker. On WinRT, it's far more simpler because they use the COM technology. Basically, COM object is able to be callable across process. Basically, the sandboxes process can make an object, marshal it, and send it through an RPC port to the broker. So let's sum up all the thing. This is the Chrome layout. Imagine the sandbox process want to open a file. So it will in fact call target NT-create file, which first try to create the file with the sandboxes right. Of course, if it fails, it will write parameters on share memory and notify the share handle to say to the broker that he has something to do. On the broker side, it will retrieve parameters through the share memory, check with the on access policy if the sandboxes process is allowed or not to perform the call, and then call the NT-create file with his own right. Finally, if the function succeeds, since all process has their own handle table, it has to duplicate it and write it to the share memory to give it back to the sandboxes process. On WinRT, it's far more simpler because Microsoft designed a new API and basically the developer, without know it, will send an object through the RPC port. So it will instantiate the object, marshal it, send it through the LPC port. On the broker side, it will unmarshal it to instantiate the object in this own process context. And then it will check if the sandboxes process has a good capability SID. If so, it will open the file and use, once again, a COM object to send back the result to the sandboxes process. Just for fun, we just set up a hook at this place on the NT-LPC send wait receive on the broker side to basically see what kind of data are sent across sandboxes process and broker. So we use a simple application which just write a sentence in a file and that's it. So as you can see in bold character, we retrieve the GIUD which describes the COM interface followed by its name. And below there is a Unicode string contained in the packet. As you may notice, we retrieve the name of the file and even the messages, the line written in the file. Okay, so to conclude, WinRT provide both a new design and new API which allow to easily design a very reliable applications. They decided to rely on COM technology because it's a good choice for sharing data across process. And about the app container, it provides a good degree of isolations. It's very transparent for both users or developers. And it's a bit odd, but they decided to implement it in kernel, where they can use, for instance, receive tokens. They prefer to modify the access check function to do the same thing. We would like to thank you, the Quarks Lab team, for supporting us, the Microsoft for working with us, and finally the Hacking the Box team for the kindness. We hope you enjoyed this conference, and if you have questions, feel free to ask.
Yeah.